It is important to analyze an algorithm after writing it to find its efficiency in terms of time and space in order to improve it if possible. Means we are discussing here worst, average and best case time complexity. When it comes to analyzing algorithm, the asymptotic analysis seems to be best way possible to do so. This is because asymptotic analysis can analyze algorithm in terms of the input size. It checks how are the times and space growing in terms of the input size, the input we enter, the input we take from the user. In this, we will take an example of linear search and analyze it using asymptotic analysis. We can have three cases to analyze in an algorithm. To analyze an algorithm, we can have three cases to analyze an algorithm. First is worst case, second is average case, third is best case. Worst case, average case and best case. Below is the algorithm for performing linear search. Algorithm for performing linear search is this. Here we are taking a function search. In this function, search function, we are taking int type array and we are taking an integer type and an x. For int I, we are taking a pointer I here and we are running a loop from I equal to 0 to I less than equal to n and I plus plus. So our loop is this: if array I equal to x, return true. Else return here false. So this is the linear search algorithm, linear search case, because here we are running our loop from 0 to n and taking a condition, and if array I equal to x, then return true. So first of all, we are discussing worst case time complexity. First is our worst case analysis. जो आपकी यूजुअली डन की जाती है. In the worst case analysis, we calculate upper bound on running time of an algorithm. We must know the case that causes the maximum number of operations to be executed. Okay, maximum number of operations to be executed. For linear search, the worst case happens when the element to be searched. Okay, like an above example, x in the above code is not present in the array. When x is not present, the search function compare it with all the elements of the array one by one. Therefore, the worst case time complexity of linear search would be big O of n, where n is the number of elements in the array. Okay. So in the above case, we have big O of n as the worst case time complexity. We talk about now average case analysis. Average case analysis. It is only sometimes done. In average case analysis, we take all possible inputs and calculate computing time for all the inputs. Okay, we take all possible inputs, sum all the calculated values and divide the sum by total number of inputs. Okay, sum all the calculated values. We must know or predict distribution of cases. For the linear search problem, let us assume that all cases are uniformly distributed, including the case of x not being present in array. So we sum all the case and divide the sum by n plus 1. Following the average of case time complexity of above questions, summation from n equal to 1, I equal to 1 to n plus 1, theta I divided by n plus 1 means theta of n plus 1 into n plus 2 divided by 2 upon n plus 1. That is big O and theta of n. Now we are talking about our third case, best case analysis. Best case analysis. In the best case analysis, we calculate lower bound on running time of an algorithm. We must know the case that causes minimum number of operations to be executed. In a linear search problem, the best case occurs when x is present at the first location, only first location. The number of operations in the best case is constant, that is here only 1. If number is present on first location, we only run our loop constant time, that is 1. So our time complexity in the best case would be big O of n. So time complexity in best case will be big O of 1. So here we can discuss some important point. Most of the times we do the worst case analysis to analyze the algorithm. In the worst case, we guarantee an upper bound on the running time of an algorithm, which is a good piece of information. Okay. Most of the cases we talk worst case analysis. Next, the average case analysis is not easy to do in most of the practical cases, and it is rarely done. In the average case analysis, we must know or predict the mathematical distribution of all possible inputs. And in the best case analysis is bogus. Guaranteeing a lower bound on the algorithm does not provide any information. As the worst case, an algorithm may take years to run. Okay. So in this video, we are talking about best, worst and average time complexity. Mostly we are using worst case time complexity, and our best optimized time complexity is best case time complexity. Everyone asking you problem in best case time complexity, try to give answer in best case time complexity when any interviewer asks you a coding questions. Okay. So in this video, this is done. Now I am telling you, please join our course on our website www.coderjobs.in. On here, we are providing a placement course in which you can guaranteed got a placement up to 40 LPA. So don't hesitate to join our course, and we are not charging any money before placement. We are charging you money after placement on the basis of our income share agreement. Okay, so feel free to join us. Thank you for watching this video. Please like this video and subscribe our channel, and also share this video to among your friends. It will be great help for your friends